Hi there, folks. This is Mike coming back at you with a continuation from our previous video. In the previous video, we introduced the concept of scientific notation, and we talked about how we convert between decimal and scientific notation. We're going to wrap up this section in this video. We're going to talk about dividing and multiplying numbers that are in scientific notation. And we do so in a pretty straightforward fashion. We had the first portion of our number in scientific notation. I call that the C value. And then there was the 10 raised to some power that followed it. And when we multiply and divide numbers in scientific notation, we will divide or multiply the C values, and we will divide or multiply the 10s raised to some power. And when we multiply or divide those guys, that's where these properties of exponents will kick in, so we can simplify those 10s being raised to some powers. In certain cases, though, we may need to do an extra step. It may not be just as easy as multiply or divide C values and multiply or divide the 10s. But let's do some sample problems here. Starting off pretty nice. 2.4 times 10 to the 4th times 3.5 times 10 to the 9th. These are some sizable numbers. We wouldn't necessarily want to write these things out and write the whole thing out. That's just not pretty. So as I said, we are multiplying numbers. So I'm going to multiply my C values, the things before the 10 raised to some power. So 2.4 times 3.5. And then it's times 10 to the 4th times 10 to the 9th. And I will change my notation here to remain consistent. So this would be a good time to pull out your scientific calculator. If you do 2.4 times 3.5, you come up with 8.4 times 10 to some power. We have that product rule for exponents. I'm taking the product of two exponential expressions where the bases are the same, so I'm going to add their powers, and that sum becomes my new power, and 4 plus 9 is equal to 13. Next one, 5.7 times 10 to the 2nd times 7.1 times 10 to the 3rd. So once again, multiplying those C values, 5.7 times 7.1 times, and then 10 to the 2nd times 10 to the 3rd. Okay. Well, if you do 5.7 times 7.1, we get 40.47 times 10 raised to the 5th power. Adding those two powers gets me 5. Now, you may stop here and think that your work is done. It's not. This number here is not in scientific notation. It's not in scientific notation because if we look at our C value here, that is not a number where there is only one digit to the left of the decimal place. That there's the 4 and the 0. So we need to work with that so that we change it into something so that there's only one digit to the left of our decimal place. Now we can clearly do that by just taking this decimal point and moving it over here. If I move it one place to the left, then that would give me 4.047. And that part's good. But because we moved this decimal point over here, since we moved it to the left, that's going to impact the power that we have on our 10. If we move it here, if we move it 1 point to the left, or one place to the left, to balance that out, we have to raise our exponent by 1. For every place you move to the left, raise your exponent by 1 to keep things balanced, to even that out. So it's not going to be 10 to the 5th, it's going to be 10 to the 6th power. And this right here is your final answer. This is your answer in true scientific notation. Okay. We'll do the 4th one here. I'll let you try the 3rd one on your own, and we'll go through that in class. So negative 3.52 times 10 to the 7th divided by 7 times 10 to the 4th. Well, similar to the previous couple problems, when we were multiplying these numbers, we multiplied the c values. Here we're going to take the quotient of the c values. Negative 3.52 divided by 7 times, and then the 10 to the 7th divided by 10 to the 4th. Okay, so if you go into your calculator and do negative 3.52 divided by 7, if we round this value to, say, 4 decimal places, we will get negative 0.5029 times, and then if you do 10 to the 7th power divided by 10 to the 4th power, this is a quotient of exponential expressions where the bases are the same. So I'm going to keep the base, and I'm going to take the difference of the powers. Top power minus bottom power. So 7 minus 4 is equal to 3. Now, once again, you may think, okay, we're done here. But again, this is not in scientific notation. It's because we need to have this so that this c value is a number that in absolute value is between 1 and 10. So to do that, I can do that by taking this decimal point and moving it 1 place to the right. And when I do that, that would give me negative 5.029. So that's good. That's what we want. But now I have to change the exponent on my 10 to help balance that out. So negative 5.029 times 10 raised to what power? Well, when we moved the exponent the decimal point, 1 place to the left, we added 1 onto the power. So now when we move it 1 place to the right, we're going to subtract 1 from the power. So it's going to be 10 to the 2nd power, not 10 to the 3rd. Always think, if you're moving your decimal point to the left, you're going to increase your power. If you're moving the decimal to the right, then you're going to decrease your power. So as I said, I'll let you try the 3rd one here on your own, and we will go through this problem in class. So that concludes our video, and that concludes this section on scientific notation. In the next video, we are going to be coming to another type of an algebraic expression, one we'll be working with a lot in the remainder of this course, as well as a lot in higher level math courses, and those are polynomials. If you have questions or comments, be sure to reach out to me, guys. Emails, texts, phone calls, office visits. Stop and see me in the tutoring center during tutoring hours. whatever you need to do. Until the next video, take it easy, guys.